Assalamualaikum and hi, my name is Nur Ainina Izzati binti Rosdi with metric number 280541. Today I will present about the question 1 for individual assignment. The question given is, discuss and sketch the following function for fx equals to x to the power of 5 minus 5x to the power of 3. Here is the 5 important steps that we need to find to solve this question. First, find x-intercept and y-intercept. Second, find the open interval where the function is decreasing and increasing. Third, find the x-coordinate of the inflection point. Fourth, find the open interval where the function is concave up and down. 5. Find the local minima and local maxima. And the last one, we need to sketch the graph of the function. Okay, now we go to the first step, which is find x-intercept and y-intercept. First, to find y-intercept, we need to set x equals to 0 for the equation fx equals to x to the power of 5 minus 5x to the power of 3. We need to substitute x equals to 0 and we get 0. So here the y-intercept is 0, 0. Next, to find x-intercept, we also need to set y equals to 0. Here, we just substitute fx equals to 0 and then we factorize the equation like this. Next, we need to set the factors equals to 0. For the first one, x cubed equals to 0 and we get x equals to 0. Second, x squared minus 5 equals to 0. And lastly, we get x equals to negative z5 and z5. So here, x-intercept is negative z5, 0, 0, 0, and z5, 0. Now we go to the second step, which is we need to check whether the intervals of fx is increasing or decreasing. To determine whether the intervals where fx is increasing or decreasing, we need to use first derivative test. From the equation fx equals to x to the power of 5 minus 5x cubed, we can get 5x to the power of 4 minus 15x squared. And we can factorize this equation, it will become like this. Now we let f prime x equals to 0. And the equation is 5x squared bracket x squared minus 3 equals to 0. We divide into 2, 5x squared equals to 0 and we get x equals to 0. For the second, x squared minus 3 equals to 0 and we get the x is plus minus z3. So the last one, x equals to 0, x equals to negative z3, and x equals to positive z3. And we can conclude that this is also called as critical point. Okay, from the previous slide, we already got the value of x, which is negative z3, 0, and z3. So here we plot the value of x on this number line so that it will be easier for us to find the interval of x. So this is the result. Okay, I use the test value, which is negative 2, negative 1, 1, and 2. For the first column, when we substitute negative 2, we got here positive, here positive, negative, negative. And the last for the f prime x, we got positive. So for the second column, I use the test value negative 1. For the first column, it will be the same, positive. When we substitute negative 1, here we got positive, positive, negative, and the last one we got f prime x equals to negative. For the third column, I use the test value equals to 1. So when we substitute, we got positive, 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 negative, and for the f prime x, we got negative. And the last column, for the x greater than z3, when I substitute the value of x equals to 2, we got positive, 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 and for the f prime x, we got positive. So, how we know whether the fx is increasing or decreasing? We see here, positive is greater than 0, so that means fx is increasing in negative infinity, negative z3. For the second column, we got negative, which is smaller than 0. We can calculate that this is the fx is decreasing in negative z3, 0. For the third column, f prime x equals to negative, which is smaller than 0, it will be decreasing in 0 set 3, and the last we got positive, which is greater than 0, it will increase in set 3 infinity. Okay, to find the local maxima and local minima, we can find this from the first derivative test. Since we know that f prime x equals to 0 at x equals to negative set 3, 0 and set 3, so the critical point is negative 3, and negative set 3, 0 and set 3. For x equals to negative set 3, we can let x1 equals to negative 2 and x2 equals to negative 1. When we substitute into the f prime x, we can get for x equals to negative 2 greater than 0, for x net equals to negative 1, we got smaller than 0, and for the f prime negative set 3, we got 10.3923. So here, this is the local maxima, which is 10.3923. And for the x equals to set 3, we need to let x1 equals to 1 and x2 equals to 2. So we got negative 10 and 20, which is negative 10 smaller than 0, 20 greater than 0. And for the f prime set 3, we got negative 10.3923. So here is the local minima, which is negative 10.3923. While for x equals to 0, there is no local maxima and or local minima for these x values. Okay, next we need to find the x-coordinate of the inflection point. To find the x-coordinate of the inflection point, we need to use second derivative test. So here, from the previous equation, fx equals to x to the power of 5 minus 5x cubed, we find first derivative test, we got 5x to the power of 4 minus 15x squared. And for the second derivative, we got this, which is 20x cubed minus 30x. And we can factorize this equation and become like this. So we need to let f prime x equals to 0, then 10x bracket 2x squared minus 3 equals to 0. First, for the 10x equals to 0, we got x equals to 0. And for the second, 2x squared minus 3 equals to 0. For the last x, we got plus minus set 3 over 2. Okay, hence the coordinate of the inflection point is x equals to negative set 3 over 2, 0 and set 3 over 2. Now let's go to the next slide, which is to find the upper interval where the function concave up and down. We need to plot the point of x, which is negative set 3 over 2, 0 and set 3 over 2. And we can use we can build the table to know the sign, so that we can know whether function is concave up and concave down. So for the first column, x smaller than negative set 3 over 2. For 10, we got positive. X, we got negative. Here we got negative, negative. And for f prime x, we got negative. Second column, when we substitute any of interval of x here, we can get positive, negative, positive, negative here. And lastly, for f prime x, we get positive. Third column, when we substitute any value of x here, we got positive, 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 and negative. And for f prime x, we got negative. For the last column, x greater than set 3 over 2, we got positive, 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 positive. And we get, for f prime x, we got positive. So, since negative is smaller than 0, so we can conclude that this is concave down in interval infinity negative set 3 over 2. For the second column, positive is greater than 0. We conclude that this is concave up in negative set 3 over 2, 0. Third column, we got negative. We conclude that concave down in interval 0 and set 3 over 2. And the last one, we got positive, which is greater than 0. We can conclude that this function is concave up in the interval z3 over 2 infinity. Okay, after we get all the values of x, for the last is we can find the corresponding f values for all points that we get just now. Okay, like we know the previous equation fx equals to x to the power of 5 minus 5x cubed, and when we substitute 0, x equals to 0, we got 0, so the point is 0 0. Second, we substitute x with z3, we got negative 10.3923, and the point is z3 negative 10.3923. For the third column, we substitute x equals to negative z3, we got 10.3923, the point is negative z3 10.3923. For the fourth column, we substitute x equals to we substitute x equals to z3 over 2, we got negative 6.4299, and the point is z3 over 2 negative 6.4299. The last column, we substitute x equals to negative z3 over 2, and we got 6.4299, and the point is negative z2 6.4299. So this is the last part to solve this question, which is you need to sketch the graph of the function. Don't forget, okay? So to sketch this graph, we need to plot all the corresponding points that we found just now. That's why we need to find the points so that we can sketch the graph correctly and make sure the plot of the graph is plotted correctly. So after plot the graph, we sketch the graph neatly, and we got like this. And from this graph, we can also see that the function concave up, concave down, increasing or decreasing. Okay, I think that's all from me, and I hope you enjoy watching my video, and stay safe and goodbye.